Hello everyone. Today I'll be sharing you the concept of buffers and how do you actually use them in your exam point of view and many more things. Okay. First of all, what is a buffer solution? It is nothing but it looks like some aqueous solution and in that you have a mixture of a weak acid and its conjugate base, or you can have a weak base and its conjugate acid also. This is actually a buffer solution. And if you take a buffer solution and add some strong acid or some strong base also, you will have a very negligible amount of change in pH, which means it resists the change in pH. Okay, for example, you can have acetic acid and acetate ions. So this is a weak acid and this is a weak acid, acetic acid, and this is a strong base. I mean, its conjugate base is actually strong. That is, so it forms a buffer solution. Okay. So coming to the types of buffer, there are two kinds, which is a simple buffer and a mixed buffer. So simple buffer is nothing but it is made up of a weak acid and a weak base. So if you see here, the first example, it is made up of acetic acid, which is a weak acid, and this is NH4OH. This is also a weak base, and similarly, this one also. And if you come to the side of mixed buffer, there are two kinds: acidic buffer and basic buffer. In acidic buffer, you have a strong base and a weak acid. Like here you have, this is formed when NaOH is reacted with acetic acid. And if you come to see a basic buffer, it is made up of a strong acid and a weak base. So what is the component of weak? I mean, it can be an acid or weak acid or weak base. It is that kind of buffer. Simple as that. Okay, coming to acidic buffer and how can we tackle problems when you face in your examinations. So this can be given as the Henderson-Hasselbalch equation, which is written over here. So you should derive this equation, and this equation came from your normal equilibrium equation, and this last formula is important according to your examinations. This pH formula, this pK is dissociation constant of an acid. So you should remember this formula when you'll get some mostly direct questions in your NEET examination or JEE examination papers. So you can directly use this formula if you have an acidic buffer. And if you have here, what is the pH range means? pH range of an acidic buffer can be defined as your pKa, which is your pKa plus or minus 1. If you have, if suppose your pKa value is 6 and your pH, maximum pH range can be between of a buffer solution. Remember, pH of a buffer solution can be it can be between 5 and 7. It can have any value. So it actually allows a minimum change in pH values. And maximum buffer capacity is always achieved when your pK is equal to pH, which means you can also clearly see from this equation when this log component becomes 0, you will have pH is equal to pK, which is actually the maximum value that a buffer can achieve. And coming to basic buffer solutions, this is also the same equation which we have derived for the acidic one. So you should remember this. This is pH, so you should subtract it like if you want to find pOH, you have to make it like pOH. Instead of pKa, you should put pKb if pKb is given. which is dissociation constant of a base. And you can put this equation, and you can also write POH is equal to 14 minus pH, and by that also you can have your POH values. And your maximum buffer capacity here is also achieved when your pKb is equal to POH. Okay. And your POH ranges, POH is pKb plus or minus 1, as I stated before. The same is for acidic and basic buffer, just that you have to put the correct dissociation constant values. And the next one is buffer capacity. It is like you have to add number of moles of strong acid or base to your buffer solution. To 1 liter, you have to take a 1 liter of buffer solution and add a strong acid or base. And when the pH changes by 1 unit, you measure that value. That is your buffer capacity. Okay. So this measures the effectiveness of buffer, which means your buffer is how much efficient is it. This is measured by buffer capacity. So larger the value of buffer capacity, more resistant is the solution to change in pH, which means it won't change its value from its original pH value. So you can also calculate it by this formula. Buffer capacity is equal to number of moles of H plus or OH minus ions added divided by pH change and volume of buffer in liters. Next, coming to buffer in a biological system. This happens in every one of us. Like in tissues, it happens like basically you have a bicarbonate ion in your red blood cells, your RBCs, which actually is a diprotic part. So it can lose hydrogen, which I'll show you here. You have your tissues will release CO2 into the blood in your RBC, and your RBCs are having this bicarbonate ion, right? So this bicarbonate ion, what it will do, it will be there before also, and your blood will also have some amount of water in it. So this carbon dioxide combines with water to produce this bicarbonate ion also. So this on dissociation gives this will protonate, I mean deprotonate, and you will have a release of hydrogen ion. So this is happening in tissue level. If you come to the level of lungs, where CO2 is accepted by the lungs, this reaction goes in an opposite manner as that of tissues. This hydrogen will combine with this HCO3 minus, and you will have a bicarbonate thing, and that will dissociate to give water and carbon dioxide, which means equilibrium is maintained in our blood vessels. This can be also given like this, as I have given here. Your water and carbon dioxide combines to give carbonic acid, and this releases hydrogen and bicarbonate ion, and this will also give 2H plus and CO3 minus. So thank you. Keep watching.